All right, so since we have different isotopes of certain elements, that means each atoms can weigh different amounts, right? A neon 22 will weigh more than a neon 20. And so on our periodic table, we have masses on there, right? You can see the mass of hydrogen is 1.008. The mass of calcium is 40.078. So what are these masses? They're average masses, right? Also sometimes called the atomic mass, if you will. And so these are just calculated based on an average. So this is what's known as a weighted average. And so our atomic mass, or our average mass, is just going to be an average. So that's a sum. So this little crazy symbol means a summation or a sum of the percent abundance of that isotope, written as a decimal, times the mass of that isotope. And then depending on how many isotopes there are, you want to do that for each one, and then you add them all up. So let's go ahead and take a look at an example. Chlorine. So in case of chlorine, 75.77% of chlorine is Cl35, which has an atomic mass of 34.97 AMUs. And then the rest of it, the 24.23%, is chlorine 37, which has an average, has a mass of 36.97 AMU. And so now what we want to do is we want to calculate the atomic mass. So it's going to be a sum of the parts. The main thing that we have to be careful of is we have to write them all as decimals, right? So if you have a percent, to take it to a decimal, you just divide by 100, right? So you take your percent, divide by 100, and then you'll get to the decimal form. So for example, we can take this 75.77 and we can change that to a decimal by dividing by 100, you get 0.7577. And then we take that, we multiply by its mass, which is this 34.97 AMU. Right, so that's our first part, that's for that first isotope. And then what we want to do is sum or add the other isotopes, right? So in this case, we've got 24.23% to divide by 100 to make it a decimal. That'll be 0.2423 multiplied by its mass, which is 36.97 AMU. Right, and then we just whip out our handy dandy calculator, plug it all in there, and then get our atomic mass. What you'll get here is 35.4546, which in this case will round to 35.45. We'll later learn the rules of rounding and sig figs later, so don't really worry about them too much right now, but this would round to 35.45. And then if we check our periodic table, chlorine, we see 34.45, right? We didn't calculate this last number. We only have 4 sig figs. We'll learn about that later. Don't worry about it for now. If you'd like, you can just write out your answers to as many digits as your calculator shows. And so that's how we calculate the average atomic mass. In this case, we only had 2 isotopes, but you can have more than 2. And it's the same process though, right? Your atomic mass will just be the sum of its parts, right? So you'll take your percent as a decimal, multiply it by the mass of that isotope, add in the next one, right? Percent as a decimal times the mass. And then in this case, if you have 3 isotopes, you would do it another time. If you had 4, you do it another time, 5 another time, so on and so forth. You just want to add up all your parts. Of course, a little bit of practice will make you perfect at this. Cool.